cosmic secrets revealed. Beyond time, beyond space, beyond imagination.
Have you ever gazed up at the night sky and wondered what's out there? For as long as we can remember, one celestial body has captured our imagination more than any other: Mars, the red planet. It's been the stuff of legends, of science fiction, and of our wildest dreams. But what if I told you that those dreams are on the verge of becoming reality? NASA isn't just dreaming about Mars anymore. They are actively planning to make it humanity's second home. This isn't a movie plot. It's a mission that's already in motion, a grand endeavor that could redefine our very existence. In this video, we're going to dive deep into NASA's bold, ambitious, and utterly fascinating plan to colonize Mars. We'll explore the why, the how, and the what's next in this incredible journey. Forget what you think you know about space travel. We're about to embark on an exploration of the next great chapter in human history. So buckle up, because we're heading for the red planet. So why Mars? Out of all the planets in our solar system, why focus so much energy, time, and resources on this cold, distant world? The answer is surprisingly simple. Mars is the most Earth-like planet we can realistically reach. Think about it. It has seasons, just like Earth. It has polar ice caps, holding vast reservoirs of water ice. Its day is just a little over 24 hours long, a familiar rhythm for future inhabitants. Now, let's be clear. It's far from perfect. The atmosphere is incredibly thin, about 1% the density of Earth's, offering little protection from solar radiation. Temperatures can plummet to bone-chilling lows. It's a harsh and unforgiving environment. But here's the crucial part. It's the best shot we've got. It has the foundational elements we need to potentially build a self-sustaining outpost: water, sunlight for power, and a day-night cycle we can adapt to. Other candidates, like Venus with its crushing atmosphere and hellish temperatures, or the gas giants with no solid surface, are simply out of the question with our current technology. Mars represents a challenge, yes, but a solvable one. NASA firmly believes that with the right technology and unwavering determination, we can overcome these hurdles and take our first steps toward becoming a true interplanetary species. NASA's roadmap to the red planet doesn't actually start with a direct flight to Mars. Instead, the journey begins much closer to home, with our familiar celestial neighbor, the Moon. This strategy is called the Artemis program. The name is no accident. In Greek mythology, Artemis was the twin sister of Apollo. Just as the Apollo program took us to the Moon for the first time, Artemis aims to take us back, but with a much bigger goal in mind. This time, we're going back to stay. The plan is to establish a sustainable, long-term human presence on and around the Moon. This includes building a lunar base, the Artemis Base Camp, and an orbiting outpost called the Gateway. Why is this so important for a Mars mission? Because the Moon is the ultimate training ground. It's a harsh, airless environment where we can test the technologies and systems we'll need for Mars. But it's only a 3-day trip away. If something goes wrong, help is relatively close. Astronauts will gain invaluable experience living and working in deep space, learning how to use local resources, testing new habitats, and perfecting the complex operations required for a mission that's orders of magnitude more difficult. The Moon isn't just a destination. It's the essential stepping stone, the dress rehearsal for humanity's next giant leap. The journey from Earth to Mars is a marathon, not a sprint. We're talking about a voyage that will last anywhere from 7 to 9 months, depending on the alignment of the planets. During that time, astronauts will be confined to a relatively small spacecraft, hurtling through the vacuum of deep space. This presents a whole new set of challenges that missions to the Moon never had to face. For starters, there's the constant threat of radiation. Outside the protection of Earth's magnetic field, astronauts are exposed to high-energy cosmic rays and solar particles that can damage DNA and increase long-term health risks. So, Advanced radiation shielding is non-negotiable. Then there's life support. You need a closed-loop system that can recycle air and water with near-perfect efficiency for months on end. You need to pack enough food or figure out how to grow it along the way. To propel this interplanetary vessel, NASA is developing incredibly powerful hardware. The Space Launch System, or SLS, is the most powerful rocket ever built, designed to lift the heavy payloads needed for such a long mission. This rocket will launch the Orion spacecraft, which will carry the crew, and connect with a deep space transport vehicle in orbit, the Interplanetary Cruise Ship, that will make the long trek to Mars. Every component, from the engines to the onboard computers, must be robust and reliable, because once you're on your way, there's no turning back. After a journey of over 300 million miles, the most critical phase of the mission begins: landing and establishing a foothold on Mars. This is where science fiction truly starts to become engineering fact. NASA's plan isn't just to plant a flag and come home. The goal is to set up a sustainable base that can support astronauts for long-duration stays and serve as a nucleus for future expansion. The first priority upon landing will be to deploy habitats. These could be inflatable structures that are lightweight and compact for transport, but expand to provide a spacious living and working area on the surface. But you can't bring everything from Earth. It's just too expensive and impractical. The key to long-term survival is using what's already there, a concept known as in situ resource utilization, or ISRU. Mars has a treasure trove of resources right beneath its rusty soil. We know there are vast deposits of water ice, especially near the poles. Using specialized equipment, astronauts could mine this ice and split the water molecules into breathable oxygen and hydrogen fuel for return trips. The thin Martian atmosphere, which is mostly carbon dioxide, can also be processed to generate more oxygen. And for power, large arrays of advanced solar panels would be deployed to soak up the sunlight, keeping the lights on, the heaters running, and the entire colony alive. This first base, built with a combination of Earth-brought technology and Martian resources, would be humanity's first home on another world. So, what would it actually be like to live on Mars? It would be a life unlike anything anyone has ever experienced. Imagine waking up not to a blue sky, but to a pale pink or butterscotch-colored one. Looking out your window, you'd see a vast, rust-colored desert under a sky with a sun that appears slightly smaller and dimmer than what we're used to. One of the first things you'd notice is the gravity. Mars has only about 38% of Earth's gravity, so you'd feel incredibly light. You could jump 3 times higher, and lifting heavy objects would be a breeze. While that sounds fun, it would have serious long-term effects on your bones and muscles, requiring a strict exercise regimen to stay healthy. Life would be lived inside pressurized habitats or in advanced spacesuits whenever you venture outside. You'd have to constantly be on the lookout for massive, planet-engulfing dust storms that can block out the sun for weeks at a time, crippling solar power systems. And then there's the psychological challenge of isolation. You would be millions of miles from home, living in close quarters with a small group of people, with a communication delay of up to 20 minutes each way. The psychological resilience required would be immense. But despite these challenges, it would be a life of profound purpose. Every day would be a day of discovery, of pushing boundaries, and of building a future for humanity. It would be the beginning of a truly multi-planetary civilization. Colonizing Mars is, without a doubt, one of the greatest challenges humanity has ever set for itself. It's an undertaking that will test the limits of our technology, our finances, our scientific knowledge, and our very endurance as a species. The obstacles are monumental, from developing rockets powerful enough for the journey, to designing life support systems that can operate flawlessly for years, to protecting astronauts from the harsh radiation of deep space. It will require unprecedented levels of international cooperation, innovation from countless engineers and scientists, and a collective will to venture into the unknown. But it is also, perhaps, our greatest adventure. Think about the turning points in human history. The moment our ancestors first controlled fire, the invention of the wheel, the first voyage across the oceans, the first flight. Landing on Mars and establishing a permanent colony is a challenge on that scale, a moment that will be remembered for thousands of years. If NASA and its partners succeed, it won't just be another mission checked off a list. It will represent a fundamental shift in our place in the universe. It will be the moment we stopped being a species confined to one planet and started living among the stars. The journey will be long and difficult, but the destination is nothing less than a new future for all humankind. Thank you so much for joining us on this incredible journey to the Red Planet. If you're as excited about the future of space exploration as we are, make sure to hit that like button and subscribe to our channel for more deep dives into the science and technology shaping our world. What part of the Mars mission excites you the most? Let us know in the comments below. We'd love to hear your thoughts. Until next time, keep looking up.